In this video we're going to work through the steps to create something that looks like the dish you can see in the photograph. This is a two-sided project, and the idea that I had for it is I wanted to make a piece of wood look as if it was a sort of suspended piece of flowing cloth. So one of the main things we're going to look at is how to model and sculpt that kind of flowing cloth shape using the two-rail sweep function as a basis for it. Next we're going to look at how we can set this up to make a two-sided part. So here's another photo that shows how thin the material is, and we're going to look at the ability in the software to do an offset of the 3D model in order to create the underside of the shape. Here's another photo, this is of the underneath of the dish, and then finally another photo from a different angle of the top, again so you can kind of see those flowing lines. So let's open a new copy of Aspire to begin. Let's open an existing file, and from the project folder I'm going to select the file called clothdishvectors.crv3d, and as you can see this has a selection of vectors that I've already created in it. These have been placed on 3 layers. The toolpaths layer has the basic square outline of the dish that ultimately we're going to use to cut the part out. On the dish vectors layer we have the shape that's going to give us the actual form of the dish, so that we have a lower area in the middle and an area that raises up towards the edge. And then the wave vectors are just some that I've literally just sketched into here. There's nothing special about these, there's no sort of premeditated shape, they were just sketched in order to create kind of an uneven wave. We're going to use these as the sort of seed to create the shapes that we're going to turn into our cloth. So we can keep them in context, I'm going to keep the toolpaths layer switched on so we know where the outline of the part is. We'll just make sure wave is the current layer and hit close. So we'll go over to the modelling tab and start to create our cloth shapes. What I'm going to do is just create a two-rail sweep between these two vectors as the rails, and then these two will make up the cross sections. So I'm going to select the top one, shift and select the bottom one, go into the two-rail sweep function and click on the Use Selection button so we can check the start points line up and the direction is good. Then I'm just going to select the first one and click on the left hand end, and select the second one here and click on the right hand end there. So I can see that's placing the red one on the left, the yellow one on the right, so it's basically going to try and sweep between those two shapes. In this case I'm going to uncheck scale cross sections with width and uncheck sweep between spans. I'm also going to uncheck scale to exact height here as well, and we'll just call this wave 1 and hit apply. Now we can see that there in the 2D view. Should also hit page up on the keyboard so we can tile the windows, 2D view on the left, 3D view on the right, and we can see the shape that has created for us. I'm going to close the two-rail sweep form now. Now the idea of creating something that looks like a flowing piece of cloth in a digital software environment means that we're really working in a very subjective area. So the method I'm going to show you here is just one way I've found of creating something like this, but there may be many other valid methods as well. So I basically worked with this single piece here and then decided to make copies of this, distort them a little to add a bit more difference to the flow of the cloth, and then ultimately get in there with the sculpting tools, because they're what's going to give you the ability to really change the shape of this to make it look smooth and flowing. So to start with, I'm going to take the component we've created here, click on it again to go into transform mode. I'm just going to click on the bottom here and stretch this up, or actually compress it rather than stretch it, so that we've got it roughly halfway up in the model. Then I'm going to hold down Control, Shift and V and make a vertical copy of that below. Now you can see if we just double click in the background to deselect, as these overlap they're starting to just blend together, and that's because I made sure that the edge of these components came down effectively to a flat level. So if I zoom in and go to node editing, you can see that this particular control point is exactly in line with the edge, and I ensured that I did that with both ends of my cross sections. Now we can start to take these and maybe just stretch them up a bit more. Maybe we want to stretch it out, but really to add a bit more difference into the shape rather than just stretching, pulling and pushing and mirroring them. What I may want to do is actually flip sideways, so let's hit H on the keyboard to go horizontal there, so now we've flipped that over, and then also go in and use the Distort Selected Objects tool. So if I click on that, hit Apply, so we get a bounding box around it. Now I'm going to hover over the edge, I'm going to hit B on the keyboard to add in Bezier spans on all 4 edges, so you'll see the control points appear there. And now we can start to play around with what this shape is doing. We can move the control points, we can move the actual main points in the part as well. And you can see this just allows me to create a different kind of flow and feel to the shape than the original one that we've got. So if we like the look of that, we might want to bake the distortion there, and then just select this one. And I say there's no right or wrong answer to this, it's really just a case of playing around, going in with the distortion tools here and seeing what you think looks interesting. So this is something that we could really spend a long time doing if we wanted. At this stage I'm just going to go with that because there's really, as I say, no right or wrong answer to this. It's just a case of giving us a sort of a basic seed shape to work with the sculpting. If we hit Bake Distortion on that one as well and hit OK, and now what I may want to do is take both of these and bake them together. So I'm going to select them both and hit the bake icon, and then we might even distort that a little bit more. So we can go in and out as many times as we want, joining the shapes together, changing them around in order to do different things with the way the material flows through. So that looks okay. I'm going to hit Bake Distortion again, hit OK, and then just close the Distort Object function. Now let's come over and just right mouse click and rename, and we'll just call this Cloth 1. And I'm going to select this component now, and the next thing I want to do is just start sculpting it. So let's maximize the 3D view. Now ideally you would do this with something like a Wacom tablet or a stylus. I don't have one on this computer, so I'm just going to use a regular mouse for this, which gives me a little bit less control, but we still should be able to create something interesting with it. Now the sculpting mainly consists of smoothing and smudging in order to just add a bit more interest and flow into this. So with the object selected, the component selected, I'm going to click on the sculpting icon here. And I'll probably start by doing a bit of smoothing, and I'm going to uncheck Preserve Transparency, quite a high diameter here. Strength, we'll go around 3/4 there, that's fine, and the smoothness is okay. And if we just start to go around the edge, I just like to begin by kind of evening out the edges here, which means that when I start to smudge, I won't get such a harsh extension of them. So we could almost go all the way out to the edge of the model there and just kind of fill in those gaps. Now we can come in here, smudge within the shapes as well if we want to. So once again, this is something that you may spend a good few minutes doing, just to give you a kind of a starting point to work with. Then eventually we're going to go for the smudge. Now the smudge has a lot more of an effect on the model. I'm going to go for quite a high diameter. I'm going to start with the strength turned down to about 30, and we'll just start pulling and pushing this around. And you can see the way this works is I need to click and drag in order to extend the shape, or if I click in a low area and drag inwards, then that'll reduce the height of the shape down. Now at the moment, with the strength set to around about 30 there, this is having a very gentle effect on my part. So I would need to go over it a lot of times in order to start to change it. And you can see what I'm doing here is just dragging this peak over and out into the side or into the trough next to it. And this is something, if you look at a piece of cloth, it doesn't just go across in uniform waves like this. It kind of tends to happily go between the peaks and the troughs. If we want to increase the strength, we can, and just continue to play with this, going back and forward into the part. As I say, there's no really right or wrong answer to this, but it's good to look at some photographs of different pieces of cloth so you can start to see how it might flow. The key word there that I just used is this idea of flow, so it's kind of continuing and pulling and pushing things out in order to create this effect of a flowing piece of cloth. And you can see this is already starting to create quite interesting transitions. Now literally you could continue to do this type of operation for 10, 15, 20 minutes, keep working on it, playing with it, trying different things until you are completely content with the finished part. In this case I'm not going to spend that kind of time showing you in the video. You've seen the main process, the smooth tool and just smoothing areas out, and then the smudge tool here, high diameter and sort of low to medium strength. If you go up to high strength, you're going to really start to probably introduce creases and things that you don't want, that won't give you the same level of flow. But play around with it and see what happens. So we'll assume that we'd spend a bit of time doing this. In this case, I'm just going to hit OK on this, and I'm actually going to delete that one, and I'm going to come up and import a file that I've already created, and this is one that is based on the same model that I showed you in the photographs at the start of the video. So from the project folder I'm going to import a 3D model, cloth V1, and hit open. And there you can see the finished version of what I created here in the software. So hopefully you get a sense of the fact that we were on our way to this, based on the point that we'd got to with the sculpting, and if we continued for about 10-15 minutes then we could end up with something that looks like this. A couple of key things to mention before we continue. In this I have aimed to try and smooth down the corners. If we look at this in the 2D view, in the context of the part we're going to cut out, you can see that I've really tried to bring this back down to 0 in the corners of the part, and that's because I want the dish to be able to sit on its 4 corners there. So that's quite important in the way I've sculpted this, and that may be something that again you'd need to play around with and just make sure you understood where those corners were. The other thing that's important about this is the original resolution that I set the job at. If we go to set job dimensions and origin, my modelling resolution was set to high rather than standard or very high, and that's because I knew the type of sculpting I was going to do. If I set it to very high, then the maximum size of the brush that I'd be able to use in the sculpting would be too small. So that's why this was set to high originally. Again, this is something that's kind of subjective and you really just learn from experience. So next thing I want to think about is the height of the part here. At the moment, if we look at this and go to the properties, we can see it's set to 3/8 of an inch. So I've scaled that down before I've saved it out, and we'll need to be aware of that in a minute when we start to actually introduce the idea of the dish shape that's going to push up the edges in order to create the kind of the internal shape that we'd be able to place items into. So let's move over to the Layers tab, and I'm going to switch off the wave layer. So you can see the vectors have disappeared and also the grayscale's gone because this was the current layer when we imported that component. That's fine, I don't need the grayscale. So I'm going to switch on the dish vectors layer and I'm going to make that current. Now I'm going to come to the modeling tab, and we're going to use the same function that we did before to create the seed for our wave in order to create the dish, this time with much more regular vectors, as you can see there. If we select this one and go into node editing, you can see that the cross section for our dish is a very, very clean wave where the control points are exactly horizontal here. Let's just hit escape to go out of node editing, F to fit that. I'm going to click on the 2-rail sweep icon, select the outer rail, shift and select the inner rail, and click on the use selection button. I can see from the arrows on here that they're both flowing in the same direction and my start points are adjacent. Now I'm going to select my cross section, click to add that, and then right mouse click on the point and add to all rail nodes, so we get one top, bottom, left and right. This will just create a nice even shape for us. I'm going to make sure sweep between spans is checked, scale cross section with width is unchecked, and fill center of inner closed vector rails is checked. That'll just fill in this middle circle for us. Make sure the combine mode is set to add, and then I'm just going to call this dish, hit apply and close. And we can see there simply we've just got the cloth component and now the dish being added to that in order to create this shape here. And this is what's going to give us the effect of this kind of suspended piece of floating cloth. Now again, I've deliberately positioned this so that the shape is coming down to 0 in the corners so that I can ensure that the dish has got 4 points that it'll be able to sit on. I've also tried to make sure that I've got a low point in the middle here, so even if it sags a little, because remember this is going to be very thin material, it'll also pick up that center point to sit on as well. So there's a little bit of thought gone into some of the depths around the model at this point in time. Now at this stage I want to start thinking about the heights of my components based on the depth of material that we plan to machine. So I'm planning to use a 2-inch block of material, and that means I want to aim for a total height of around 1.9 inches. Now that needs to include some thickness that we can offset for the back side. You can see this is getting all the way down to 0 at the moment. So I'm going to actually add in a component. I'm going to go to Model, Add Zero Plane. So that adds in just a rectangular component across the whole part. I'm going to select this, go to the Properties, and I'm going to give this a base height of 1/8 of an inch and hit the space bar. So that's just raised up the model 1/8 of an inch there to ensure that I have some material to play with. Now if we look at that, that is 1/8 of an inch, the cloth is 3/8 of an inch, so they'll give me a total height of 0.5, which means for the dish I want to set the height of that to be around 1.4 inches to get me close to that total depth that I'm looking for. So if we click on the dish, go to the Properties, I'm going to enter a value of 1.4, hit the space bar. You can see that really accentuates the dish, which will be good. That'll make it easier for me to put items into. And if we close this now and just come up and click on the scale Z height of the model, we can see that that is very close to this 1.9 height that I'm aiming for. In fact, if we want to now, we could just click to set exact height for this at 1.9 inches, hit apply, and all those components will be slightly scaled up in order to fill that and make that the correct value. Now we've got the model for the top of our part ready at this stage, but I would like to toolpath the back side of this first. So what I'm going to do at this stage is add in the dowel positions that we're going to use for positioning the part when we do the two-sided machining, so that I know that they're referenced from the same position in both sides, and then we're going to save this, and then we'll save it again and do the work we need to mirror the part and offset it to create the underneath of our dish. So let's come over to the Drawing tab, and I've measured my dowels and I know that they're basically 3/8 of an inch in diameter, so I'm going to enter 0.375 here, and I'm going to click then just 3 random positions which I know to be outside of the area that I'm going to machine. The square is going to be more or less the area I'm going to cut, maybe coming out of this by another 1/2 inch or so. So they're in 3 safe positions. I'm planning to screw this down in the corners, and we can hit close now, and I've created those on the dish vectors layer, so I'm just going to select those 3 and I'm going to right mouse click and move them to the toolpaths layer. So that's the same layer as the square we're going to use to calculate our or use for the boundaries of our toolpaths. So now we can save this. I'm going to say File, Save As, and in the project folder we'll call this Cloth Dish, and I'm going to call this Side B. So as I say, although this is the top of our dish, I plan to machine this second. I'm going to machine the underneath of the dish first. So we'll call this Cloth Dish Side B and go ahead and hit Save. Now immediately I want to save this again, so I'm going to say File, Save It As, and we're going to call this Cloth Dish Side A and hit Save. And now we're going to do the work in order to convert this into the underneath of our part. So I'm not going to cover the two-sided process in too much detail in this video. Really I'd recommend watching the other examples in the tutorials that go into this method in much more depth. But it is the same process that we're going to use here, so and it is a very straightforward way of doing it using dowels for positioning. Now the main thing is, once you move on to the other side of the part, so if you remember we just saved this side of the part, now we want to convert this into the underneath. The first thing we need to do is mirror all the objects either horizontally or vertically about the center of the job. So I'm going to select all my vectors by holding down Control A on the keyboard. Then I'm going to go to the Modeling tab and holding Shift, I'm going to select all my components as well. I'm going to come up and click on the Mirror Selected Objects icon. I'm going to make sure Flip About Job Center is checked and Create a Mirrored Copy is unchecked. And then in this case I'm going to hit Flip Horizontal, but it doesn't matter. All we're doing is reversing the position of everything, including these dowel holes, and those dowel holes will only give us one solution because we've randomly placed 3 into the job here, so they're not symmetrical. So we'll say Flip Horizontal. You'll see the dowel holes flip position, and we now have a mirrored version of our part in both the 2D and the 3D view. Let's go ahead and hit close here. Just click to deselect everything. So that's taken care of our horizontal positioning when we flip the job over. The next thing I need to do is take care of making the underside of the model, which means we need to offset it to allow for our thickness that we'd like to leave of material when we cut the other side, and then invert it. To do this, I'm going to make a composite of the models that we've got here. Because we've already saved this part separately, I don't need to make a copy of these. We can just take these 3 components and we can click on the icon to bake these together. So if we right mouse click on this and rename it, we'll call this Edit Side A. Next we can do our offset command, and what we want to do is basically offset this inwards, so in a negative direction, in order to create the thickness for our part. So that should eradicate the external edge we've got here. Now if you remember, we set this to be 1/8 of an inch, but then we actually scaled all the components up, and if I hover over that I can see at the very bottom of the screen a depth of 0.1267 of an inch there, and I'd like to try and get that pretty much down to 0. So I'm going to select the component, click on the offset model icon. I'm going to enter a negative value because I want it to get smaller to create the inside of this, and then we can put 0.1267, which is just that value that we read off the 3D model there. I'm also going to ask the software to clip Z values to the 0 plane, and then we'll click on the preview button, and you can see the model just got slightly smaller there. It's very, very quick. If we hit OK now, we've got 2 models. We've got our original model, which we can switch off, and now there's the offset model. So if we just maximize the 3D view, hopefully you can see how, if we just flip between those, that has just offset that and made it thinner now, and that's a 3-dimensional offset. The next thing we want to do is invert that, so I'm going to select our offset, I'm going to rename this, and we'll just call this Side A Offset, and what we want to do is just set that to be negative, so we can just set the combine mode there to subtract, and that's going to give us the underside of our model. So the 3 separate operations we've done there, one was to mirror the part over to sort out the left and right as we flip the material over. Then we've offset it, which is going to give us the thickness. So if you remember at the very beginning of the presentation, we looked at the video and you saw how relatively thin that was. That distance was created by the offset. If you don't think the material you're planning to use will support such a thin offset, you'd need to redesign this to make sure that it had a thicker cross section. Finally, we've set it to invert so that now we've got the negative, so that when we machine this side and flip it over, we should get the exact invert and mirror on the other side when we cut it. The only other operation you might want to do before you start machining this is to smooth it a little, and that's just because as you offset something inwards you can sometimes create sharper creases within the part, and it may be worth going in and smoothing those out just a small amount in order to allow the tool to cut them nice and cleanly. So we could do that by double clicking the components, clicking on the smoothing filter icon here, just setting this to max and bake that, and we'll maybe do that a couple of times there, bake that in and hit OK. And I say that's just going to smooth out some of these areas and help the transition when we come to machine it. If we wanted to, we could also go in there and do that with the sculpting tools as well. So now we can head over to the toolpath tab, start calculating the toolpaths for this side of the job. Let's click on the icon to switch over, go to View, Tile Windows Vertical so we can see the 2D and 3D view, and the first thing we need to do is come up and click on the Set button for material setup. Now if you plan to actually machine this example, then it's very important that you calculate all the toolpaths using parameters and settings that are going to be safe and appropriate for your particular machine, the tooling you have available, and whatever material you plan to cut it into. So if we come up to the top here, we're going to set our material block to be 2 inches thick, and for this side of the job I'm going to set Z0 off the top of the part. And then when we flip it over, we're going to set Z0 off the bottom of the part, so we're always setting Z0 off the same face of material. For the XY datum, I'm going to set it to be in the lower left corner. We could keep it in the centre if we want, it doesn't matter. And that also won't matter for the other side either, because the dowel holes and the position of those and everything relative to them is what's going to give us our actual positioning of the job when we flip it over and machine those locations and then relocate the material onto them. Next, we're going to set the model position in the material so that the gap above is set to 0. On this side, I'm going to push this part all the way to the top of the material. I'm effectively treating this like a negative part, like we're cutting the inside of a dish. Next, we just check that rapid and home position is appropriate, and then we can hit the OK button. Now the first thing we want to do is machine the dowel holes from this side. And I'm planning to try and use the same tool for all the toolpaths on this side of the job, and that's going to be a 1/4 inch ball nose tool. So I just need to make sure that I cut those dowel holes deep enough to account for that ball, depending on how long the dowels are and how much is going to go into the block and how much will go into our sacrifice sheet. So in this case, I've got dowels that are about 1.5 inches long, so I'm just going to make sure that we go maybe 0.8, 0.9 of an inch on this side. So I'm going to select my dowel hole vectors from the 2D view. I'm going to click on the profile toolpath, and we're going to set this to a cut depth of 0.9 of an inch, and I'm going to select my 1/4 inch ball nose tool, and as I say, this is the tool I'm planning to use for everything on this side of the job. So I'm going to set the pass depth for this. We'll set it up at 1/4 of an inch. Step over I'm going to set to be 8% for when we get to the finishing. Spindle speed will set to be 10,000 and feed rate will set to be 180. Plunge at 30 is fine. Again, you need to make sure these are appropriate for your setup. We'll hit apply and OK. Now we're going to cut inside these shapes here, and then what we're going to ask the software to do is just permanently ramp down into them. So I'm going to say add ramps to toolpath, spiral in there, and then if we just scroll down to the bottom here, we'll just call this toolpath Dowel 025 BN for 1/4 inch ball nose and hit calculate. So that's just going to create some simple spiral toolpaths going down into there. If we preview that, we can see our 3 dowel holes. Next, if we go back to tile the windows vertical again, we can close the preview toolpaths window. Now I'm going to calculate 2 roughing toolpaths to hog away the majority of the material. One of these will be a Z-level rough designed to cut that as quickly as possible. The next will be a raster rough, which is intended to almost act as a bit of a semi-finish in this case. So we're going to select this square as our boundary. I'm going to come over and click on the icon for 3D roughing toolpath, and we're going to select our 1/4 inch ball nose tool again from the tool database, the one we just set up. And to make sure selected vector is picked here, and for the boundary vector offset I'm just going to get this to come a little bit past the edge of the part, so we'll go 0.25 of an inch, and for this Z level rough I'm going to set a machining allowance of 0.05. Raster X is fine, I'm going to set no profile on this case because we're going to come back with the raster roughing. We don't really need to profile around to clean up each of the Z levels. We could ramp if we chose to. I'm not going to worry about it in this case. We'll call this roughing Z level 025BN. So, and then we can go ahead, just one quick check over our toolpath and hit calculate. So there's the Z level roughing toolpath that we can see there. Now one thing that looks odd to me there, that looks very dense. And that is because if we double click on the toolpath again and hit edit, we've got this set up with a what's essentially a finishing step over. So it's important if we choose something like a ball nose tool for roughing, we remember to edit the step over when we're at the roughing stage. So in this case I'm going to change this step over, we'll make that 45%, hit OK and recalculate that, and now we've got a much less dense looking toolpath. It's important to try and get yourself to recognise those situations. You would expect to see a very dense blue toolpath for finishing, but not for roughing, so that immediately made me think that I maybe wanted to check something there. So now we can preview that, see how it's going to look. So there's the material hogged out. You can see these kind of cusps that we've got because we haven't gone in and profiled around, but that will save quite a lot of time in this case. Next we're going to do a similar toolpath, but this time I want to raster rough. So I'm actually going to take this one we just created and I'm going to duplicate it. Then I'm going to double click on it, and if we check the edit, that's just picked up the same parameters for the tool, even the edit to the step over. So that's why it's quite good to duplicate it. We've picked up selected vector, boundary offset. I'm going to change the machining allowance to this to 0.03 and change to a 3D raster. And in this case I think I'm going to go along Y. I'm going to go across the grain of our material, and then we'll come back and do the finish toolpath along the grain to finish that off. Now I want to make sure we change the name here, so I'm going to call this roughing raster 025BN and hit calculate. So if we just take a quick look there, you can see, as I say, that that's acting more like a finishing toolpath. Now I have still got quite a lot of levels in there at the moment. Now because I've already Z-level roughed this away, I don't need the software to respect what I would normally have for my pass depth. So again, if we just double click on that to reselect it, I'm going to hit edit here and I'm going to change my pass depth to be 2, and what that's going to do is get the software to basically do it in a single pass. So essentially, as I say, this is more like a semi-finishing pass. So I'm still using a roughing step over, still using sort of roughing type parameters, but because I've already Z-level roughed this, I don't need to do it in multiple passes. So set the pass step for 2, hit OK and calculate, and because we're doing a raster rough, the software will just project that down, respecting my allowance that we entered there of 0.03. So if we just set that to ISO and preview the selected toolpath there, we'll see what that's going to give us. So now that's done a good job of getting rid of the majority of the material on this side. And the final thing we'll do is come in with a finishing pass. So I'm going to click on 3D finishing toolpath. I'm going to select the same ball nose tool. We'll check the parameters. So 8% step over, nice clean finish on this. Selected vector. Boundary offset, I'm going to set into here to be 0.15, so just make sure the tool comes past the edge of the job. I'm going to raster this at an angle of 0, and we'll call this toolpath finish underscore 025BN and hit calculate. So now we get a nice dense blue toolpath there, and we can preview that toolpath in order to see the finished part. Okay, so really here I'm just checking that we're getting a nice clean finish there on the job. If we wanted to, we could reduce the step over, but I think that looks quite nice. Now one thing it's very important to mention on this job is the fact that this is a deep part, and so you need to ensure that your tool has the reach to get into it without the collet colliding with your material. In this case I chose a 1/4 inch ball nose tool to do my toolpaths because I knew I had one that had enough flute length on it so that I could have over 2 inches of tool protruding from the collet, and so I know I can machine this safely. If you don't have that amount of flute out of the collet, or you don't have that length of tool, then you might have to think about how you may pocket some areas out first, or you may need to just create a dish that's got less depth in it. So be aware of that. Unless you've got 2 inches of clearance with your tool from your collet, you would not be able to machine this as it is without the collet potentially hitting your material. So that at this stage is all the toolpaths we need for this side of the job. So if I knew that my material was sized correctly and flat, I'll be able to output these toolpaths, and I can actually put them all into a single file. So we could select, make them all visible with the checkbox there, go to save, output all visible toolpaths to one file, and we can actually save that as a single file using everything being cut with a 1/4 inch ball nose tool. It would cut my dowel holes, it would do our Z-level rough, our raster rough, and then our finished toolpath. In this case I'm not going to save the toolpaths, but I am going to come up, say File, Save for the parts. Now the other thing I'm going to save from this is a toolpath template, and that's because I want to apply roughly the same set of toolpaths to the other side of the job. We will make a couple of changes, but these are more or less going to be the same way that we want to machine the other side. So what we're going to do is again make sure everything's visible here. I'm going to come up, click on the icon here to save all visible toolpaths as a template, and I'm just going to call this, in fact we'll just take the name it's given us there, cloth dish, and maybe we'll just take out side A, so cloth dish dot toolpath template, and we'll save that into the project folder. So we've saved the file, we've saved the template. I'm going to go to File, Close, and then I want to come back to the other side now, or cloth dish side B. So I'm going to open an existing file and select that file, cloth dish side B, and hit open. Next I'm going to click to switch over to the toolpaths tab, and I'm going to tile the windows vertical. I'm going to load in our toolpath template, so load the toolpath template, select from the project folder and hit open, and then the next thing we need to do now is think about our material setup for this side of the part. So let's come up, click on the set button here. Let's just go into an ISO view so we can remind ourselves of the shape we're dealing with here. Now in this case I want the same 2 inches of thickness, but I want to change my Z0 to be at the bottom. So if we imagine this part is now flipped over, we've machined the other side, we've flipped over, and so my Z0 is now going to be at the bottom, and that's the equivalent of it having been on the top of material before. I'm going to set my XY datum to be in the lower left hand corner, and I'm going to make sure my gap below is set to 0. So again we're just replicating our setup on the other side of the part. We're forcing the job down all the way to the bottom of the material in the same way that we forced it all the way to the top of the material when we were working on the other side. Finally, because we're working with Z0 at the bottom of the block, I need to make sure my start position or my home position is large enough to accommodate that material plus some additional clearance, so I'm going to set that to be Z 2.5 and hit OK. Software is going to warn me I need to recalculate all the toolpaths. That's important. I'm going to do that anyway, so we can just go ahead and hit OK. Now on this side, when we machine the dowels, what's important is that we realise that that's going to be done when there's no material there. So again, we imagine we've machined the other side, we've taken our piece of material off, and the first toolpath we're going to output on this side is just to drill those dowel holes or profile those dowel holes into a sacrifice sheet, either into the sacrifice sheet attached to your machine or maybe something that you've clamped on it for this purpose. So we're going to take the same toolpath, if we double click on it, but the start depth this time is going to be 2 inches. As I say, we're imagining there's no piece of material on here, and the cut depth only needs to be enough to make sure that there's enough clearance for our dowel to go into, however much of the dowel is protruding when we flip the part over. Everything else should remain the same on here, so I'm going to just change the name here to add no material in to make sure that I don't accidentally run that. We do need to select the vectors. We didn't use anything like the toolpath vector selector on this case, so I do need to come in here and just grab these 3 vectors, and now we can hit calculate. Software should warn me that I'm going to cut through the material, and that's actually intended because I'm planning to machine this into the sacrifice sheet, as I said before. So I'm not going to bother to preview this. I can see it's below the material. That's going to be into my sacrifice sheet. After I've cut those, I'm going to take my original block with the dowels in, flip it over, and it should locate perfectly into position so that all the rest of my toolpaths will be calculated and positioned relative to those 3 dowels. So let's hit close now and just undraw the visibility on those. Next, I'm going to take my Z-level roughing, and for this time we're going to change the selection to our square, and I think I can probably pretty much take exactly the same settings as we used before. May want to increase the boundary offset a little bit in order to give us a bit of space when we come down and profile out around this, but everything else I'm just going to leave as is, and we'll go ahead and hit calculate. So that's the Z-level roughing for this side of the part. Next, I'm going to take the raster rough. Again, we might just want to extend the boundary vector offset a little there. I hit the enter button by accident there, so it's already recalculated the toolpath, but all the other parameters should be the same. Let's just double click on it to check. So got our same ball nose tool with a large step over, selected vector, 0.3 of an inch, 0.03 machining allowance, and then rastering along the Y in this case, so that looks good, and we can preview the toolpath that will give us. And then finally we can take the finishing toolpath, same vector selected, same parameters we've got here. Again, for the boundary vector offset, may want to just extend that a little bit to give us a bit of room to profile out around the outside of the job, and everything else should remain the same, and we can hit calculate. Finally, we'll preview that toolpath as well. Software will just take a few seconds to do that, and what we should see is a nice smooth version of what's going to be the top of our dish. So that all looks good. They're all the toolpaths replicated from the other side. The last thing we need to do with this example is create a profile toolpath in order to cut it out. Now we're going to cut around the same square that we've got selected from the previous toolpaths. I want to do a profile on this, and I want to cut all the way down through the material. So I'm going to set a cut depth of 2 inches. Now in this case I actually want to use the ball nose tool, although that's not the most suitable to cut it out. In my case it was the only tool I had that had the reach to get all the way into this and have over 2 inches of tool sticking out from the collet to ensure the collet wouldn't collide. So if you have an end mill that's long enough, that's fine, you could switch to that for this case, but I decided to use a ball nose and just slightly overcut past the bottom of the material. So I actually entered a cut depth of 2.05 of an inch. Now I want to cut outside the vectors, and I'm just going to let it take the number of passes that it's got set here. We could potentially look to decrease those because we're actually working partly down the side of the model, but I think for safety's sake I'm just going to let it imagine it's cutting all the way from the top of the material, and if needed run in the air for a few passes. Next I'm going to add tabs to this, and what I decided to do was put a tab on each corner because I knew that that should have material that was still pretty much on the bed of the machine. So I decided to put in quite big tabs, length 1 inch here, and then to enter a value in here of 0.2 of an inch for the thickness. Then if we click edit tabs, I just basically put one on each corner of our material, and then went ahead and we'll call this profile cutout 025BN. So again we know what tool we're using. I'm going to hit calculate and OK, and we can see it stepping all the way down there. If we preview that, we just maximize the 2D view, you can see hopefully the material that's being left in the corners there. That colour sometimes a little bit difficult to see against the background, so maybe we'll switch over to more of a wood look here, and you can see what those tabs are going to do in terms of holding the part in place. Now when this machines, you may experience a little bit of vibration because as the material gets very thin, of course it's going to want to move a little bit, but that wasn't too bad, and certainly the end result of this was something that did need some sanding in order to remove some of the tool marks and some of those vibration marks, but because of the nature of it was fairly straightforward to sand. So at this stage again we could output these toolpaths all in one file, all except the dowels of course, because they are machined with no material, but everything else still uses this 1/4 inch ball nose tool, so it could be out in a single output in a single file again and machined in one process on your CNC. I'm not going to save anything from the toolpaths in this case. I'm just going to close this now, go up to File, and we'll save this. And now that file in the project folder will include all the toolpaths we've calculated in the last few minutes. So that almost concludes this example. You've seen me work through starting by creating a kind of a seed wave shape at the beginning. Then we used the sculpting tools extensively in order to kind of smooth and blend that and create this cloth look. Next we created our dish shape using the same 2-rail sweep function in order to raise the part up. And then ultimately we looked at just adding a flat plane underneath that to create this side of the shape. Once we knew that this side of the shape looked okay and the depths were alright for the size of material we were planning to use, we drew our dowel holes, so we had a reference to those, and we saved this and called it side B because we planned to machine it second. Then I immediately saved another file called side A, and then we proceeded to do the operations on that in order to create the back side of our dish. So that involved mirroring the part around the center of the job, including the vectors. In addition to that, we offset the model to create the wall thickness that's going to be left when we machine the front and the back. And then finally we inverted it because we knew we wanted to machine from the back side of this going in to create the kind of underside of our dish. For the toolpaths, we followed a pretty typical two-sided machining method. The biggest thing, as I've mentioned a few times here, is the fact that because of the depth of this model, it's important that if you do it exactly as I've shown here, that your tool has at least 2 inches of clearance and 2 inches of flute length on it when you come to cut the part. If it doesn't, it may not cut properly, and the collet of your machine or the collet of your spindle or router may collide with the material while it's cutting, which is obviously very dangerous and certainly, if nothing else, should damage your part. That concludes this particular video. We hope you've enjoyed watching.